This is section 14.1, organizing and visualizing data. The following data represent the modes of transportation to campus of 20 students in a math course. Construct a frequency table, a relative frequency table, and a bar graph for the data. All right, so when you're in my math lab for the bar graphs, those are all going to be multiple choice. You won't actually have to construct those yourself. It'll be a little bit easier to deal with. All right, so these are the different modes of transportations that the students indicated. So frequency is how many times that response occurred. So we're looking at walk. 2, 3, 4, 5, 6. Bike is 1, 2, 3. Car is 2, 3, 4, 5. Skateboard 1, 2, 4, 5. And how many took the bus? 1. All right. So let's just total this up real quick. That totals up to 20, which matches up with what we have. So the relative frequency, that's pretty much the percentage in decimal form. So we're going to take 6 divided by 20. Let's flip over to the calculator. So I have 6 divided by 20. All right, it gives me a fraction. I need a decimal. So I'm going to hit menu, go to number, and convert to a decimal. Menu, number, convert to a decimal. And then you'll have answer decimal. You're going to have to hit enter again. And we get 0.3. So 30% chose to walk. So then we have 3 divided by 20. I'm going to put these in. 5 divided by 20. This is 0.25. And the last one, I'm going to have to do the calculator. 1 divided by 20. It's 0.05. Yeah, 0.05. So that is the relative frequency. Essentially, it is just the fractional part, but it's going to be in decimal form. So we have a relative frequency table. So walk was at 0.3. Flip back up here. Bike was at 15. Or was at 25, and skateboard was at 25. So somewhere 7.5. It's gonna be a little bit higher than that. It was the same for skateboard and car. The bus was 0.05. It's gonna be a little bit down here. So my math lab, you would just pick the bar graph that matched up with this. So let's look at this again. The following data represents the responses given by 10 students on a teacher rating website. This should say rating. The rating of excellent was 4. Rating of good was 2. Rating of fair was 2. And a rating of 4 was 1. Okay, this should sum up to 10, 8, 9, Let me see if I counted something wrong. Fair is 2. Good is 1. Was 3. All right. So I tallied that up. It didn't come up to 10. It came up to 9, which means I miscounted somewhere. All right, so relative frequency, we do 4 divided by 10. Now on the homework, they may have more decimals. This will stop at 0.4. They'll tell you what they want you to round to. 3 divided by 10. 0.3. 2 divided by 10. 0.2. My brain was looking ahead there. I know somebody was like, wait, that's supposed to be 0.3. And 0.1. Okay, so 4. 3, 2, and 1. So most of the teachers' ratings on that website were excellent or good. All right, the following are heights in inches of the players and 4 basketball teams for a recent season. Use classes of with 2 starting with 64.5 to construct a histogram. All right. So class width of 2. So let's find, they tell you to start at 64.5. See what the highest number is. 79. I have an 80. It's like 80 is the highest. So we're going to add 2 to that. So we double check that 80 was the highest. So, all right, so we need to find the number of heights that were between 64.5 and 66.5. Okay, so between 64 and 66. 1, 2, okay. So that had a height of 2. Ones that were between 66 and 68.5. Two, 3, 4, 5, 4. So that one goes up to 5. Again, this will just be multiple choice on your homework. So from 68.5 to 70.5. One, 2, 3, 4, 5, 6. I'm not gonna lie, I'm probably gonna miss. There was 5. May miss 1. All right, then from 70.5 to 72.5. So that's from, essentially we're looking at from 71 to 72. 1, 2, 3, 4, 5, 6, 7, 8. 9. So that's going to go up to 9. And then we're looking from this 73 to 74. 2, 3. I missed a 72 right there. That goes the one before. So, 2, 3. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 players. All right. Now we're looking at from 75 and 76. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then 77 and 78. 5, 6, 7, 8, 9. Miss a 75. So that was 9. I missed a 75, so this is actually 11. Okay, missed that. I missed that one right there. I missed a 78. No, this is the last. This 77, 78. I missed a 78. All right, and then the last one is from 79 to 80. 1, 2. So most of the heights are right here in the middle between 70.5 and 76.5 inches. All right. All right, we need to do 2 sets of data on a single stem and leaf plot. You may have seen stem and leaf in high school. Or middle school rather. All right, so the stem is the first digit. And we have 20s, we have 18, and we go up to 40s. So we have 10s, 20s, 30s, and 40s. We have data set A and data set B. So for data set A, let's pick all the ones where there's a 1 in the tens place. Oops. So it's just 18, 18. All right, so we have 18 twice. Then let's find the 20s. So the stem is the 2, the first 2, and the leaf is the second digit in the ones place. And it has to go from smallest to greatest inside out. So we have a 21, 22, 23, 26, and a 29. Then we need to do 30s. All right, so the smallest 30 we have is 32. It appears once. We have 33. We have a 34. The next one is 37, 38, and then 39 appears twice. We did the 18s. Then we're left with the 40s. So the smallest we have two 42s. We have three 43s and one 48. 1, 2, 3, and 48. We do the same thing for data set B. So 12, 15, the ones place. Again, smallest first, so 12, 15, and 18. Now we're going to look at our 20s. A lot of those. All right, we do have a 20, so a 0. We have two 21s, so we're going to put one twice. 3 22s. 23. 25 to 26. And then 29. Oh, we have 28. And a 29. All right, 30s. We have a 33. No, we have a 32 first. These are a little labor intensive. All right, we have a 36 and a 38 and a 39. And this one only has 140. It's a 6. So if you were to look at this, it doesn't tell us what the data set represents. Oh, so for data set B, most of the numbers are in the 20s. For data set A, most of the numbers are in the 30s. So we're going to do this again. A cosmetic company gives sales training to its newly hired employees. To determine how effective the training is, the firm compared monthly sales of a group that has completed training with a group that has not. Numbers indicated are in thousands, don't worry about that, of sales for the last month. Represent the two sets of data on a single stem and leaf display, and we're going to see if the training program works. Okay. So, what training? No training. All right, we do have something in the teens, and the highest is in the 40s. So 1, 2, 3, 4. So I'm going to start with the with training data set on top. Find the numbers in the teens. So we only have 18. And then the 20s. So we have a 1, 3, 6, and 9. Now I look at the 30s. We have a 32 and 34. And then a 38 and two 39s. Find the 40s. We have a 42, 43, 43, 43, and 48. And now we're going to look at the sales for the employees with no training. So 15 and 18. Oh, there was a 12 there. So 258. Then our 20s, we have a 20. Okay, I have a 21. Have two 22s. 23. 25 and 26. 28 and 29. 30s, I have a 33 and a 36. And the 40s, I just have a 46. So most of the sales with training were, I would say average would be around 30,000, whereas no training, they're around 20,000. So the training program does work. There are more sales with employees that went through this training program. Let's look at this next one. All right. So these are the number of customers in a coffee shop on a given day. So the first time I saw this, I'm not gonna lie, I was like, okay, this graph's a little different. So the number of customers is across the bottom. The frequency is the height of each bar. Okay. So for instance, when you look at this, there were 3 days in which the customer count was 2. All right. There were 3 days in which there were 2 customers in the store. Let's look at it another way. So there were 12 days, oops, pretend like it's a straight line. I'm going to the top of this bar in which there were 6 customers in the store. So for 7 customers in the store, we go across. There were 8 days in which they counted 7 customers in the store. All right. So now let's look at the questions. What was the largest number of customers in the coffee shop and how often did it occur? So there were 12 customers. It's the largest number of customers. And that occurred, that would be the frequency was 2 days. Okay. So 12 customers. That was for 2 days that they counted 12 customers. So what was the most frequently occurring non-zero customer count? So most frequently means tallest frequency. So if we look at the bars, which is the tallest bar? All right, it's 0, but it's which is the most frequently non-zero. So the next one down is this blue bar, and that was 6 customers. Okay. So they said non-zero, so you can't use that tall, the actual tallest one, because there were the most number of days. The one that occurred the most frequently was a 0 customer count. Or how many hours were the customers counted? Okay. Is it hours? I keep saying days, it's hours. All right. So this column 0, the height is 12, 13, 14. There were 14 hours, not 14 days, in which they counted 0 customers. And then 10 hours, 3. I'm putting the height. And this height is a 0. 1, 4, 12, 8, 5, 3, 4. That's a 0. There were 0 times in which they counted 10 customers. 1, and 2. You're definitely going to have to pop this out. So what you're going to do is you're going to add all those numbers up. We got 64. Let me add it one more time. This is actually one of the problems where I see the most errors. Okay, so it is 64 hours. For what fractional part of the total number of hours were there more than 6 customers in the coffee shop? More than 6 customers is 7, 8, 9, 10, 11, and 12. So we're going to add these up. So that's 20 hours in which there were more than 6 customers out of the 64. You will need to reduce that. So let's just flip over to the calculator. So you just put 20 divided by 64. It will reduce it. So it's 5/16. You have to make sure the fraction is reduced. And that is it for section 14.1.